Let's dive into one of the most iconic tools in chemistry, the periodic table. It's not just a chart, it's a complete story of discovery, innovation, and the unending quest for knowledge. Imagine going back thousands of years when ancient civilizations used gold, silver, and copper. They had no idea they were handling the elements that would one day form part of this fundamental scientific tool. The first true discovery came in 1649, when Hennig Brand, almost by accident, isolated phosphorus from buckets of urine. Yep, you heard that right. Fast forward to 1789, and we meet Antoine Lavoisier, who began to categorize these elements into gases, metals, nonmetals, and earths. But it wasn't until 1869 that the real game-changer came along. A Russian scientist named Dmitry Mendeleev presented the first practical periodic table. He did something incredible. He left gaps in his table, predicting that we'd discover new elements to fill them. And guess what? He was right. Mendeleev's work laid the groundwork for the modern periodic table, where elements are arranged by increasing atomic number. That's the number of protons in an atom's nucleus. The table is beautifully structured into rows called periods and columns known as groups. Elements in the same group share similar chemical properties, which makes this table an invaluable tool for predicting how elements behave. From the highly reactive metals in Group 1, like sodium and potassium, to the utterly unreactive noble gases in Group 0, like helium and neon, the table is a clear guide to the diversity of elements. And let's not forget the zigzag line that intriguingly separates metals from nonmetals, with hydrogen, a nonmetal, often making a guest appearance among the metals. So there you have it. The periodic table. It's a perfect blend of history, science, and predictability. It's not just a table, it's a storyteller, a predictor, and a relentless reminder of the wonders of our universe. Dive into it, and who knows? Maybe you'll predict the next big discovery in the world of elements. Thanks for tuning in. Now that we've uncovered the fascinating history of the periodic table, let's dive into some of its practical applications. You might be wondering, how does this table, filled with symbols and numbers, impact our daily lives and scientific endeavors? First up, let's talk about the classification of elements. The primary role of the periodic table is to identify the elements that make up matter. It helps scientists categorize and organize elements based on their properties. By breaking down the atomic structure of matter, researchers can compare it with other elements categorized on the table. This classification is vital for developing new materials and understanding chemical behavior. Next, we have the identification of elements. The periodic table is an essential tool for identifying chemical elements. It provides crucial information about each element's atomic number, symbol, and properties. In chemistry classrooms around the world, students and teachers rely on it to understand and predict chemical reactions, making it a cornerstone of chemical education. Another significant application is predicting properties. Scientists use the periodic table to foresee the behavior of elements both in their original state and when combined with other elements. By understanding periodic trends such as atomic radius, electronegativity, and ionization energy, researchers can anticipate how elements will interact. This predictive power is essential for developing new compounds and materials. Finally, let's look at balancing chemical equations. When balancing chemical equations, the periodic table helps ensure that the number of atoms of each element remains consistent on both sides of the equation. This process is crucial for chemical reactions in industries, laboratories, and environmental studies, ensuring that reactions are efficient and safe. So, there you have it. The periodic table is more than just an academic tool. It's a practical guide that helps scientists and students alike navigate the complex world of chemistry. Whether it's classifying elements, identifying unknown substances, predicting chemical behavior, or balancing equations, this table is an indispensable resource in the scientific community. After exploring the practical applications of the periodic table, let's now look ahead to its future. With advancements in technology and science, the periodic table is not just a static chart, but a dynamic tool that continues to evolve. One of the most exciting areas is the discovery of new elements. Scientists are continually pushing the boundaries to synthesize elements beyond the current table. These super-heavy elements, found in the far reaches of the table, could unlock new realms of chemistry and physics. Another promising development is the use of artificial intelligence and machine learning in chemistry. These technologies can analyze vast amounts of data from the periodic table to predict new compounds and materials with unprecedented precision. This could revolutionize industries like pharmaceuticals, energy, and materials science. Moreover, the periodic table is playing a pivotal role in addressing global challenges. For instance, researchers are exploring sustainable and eco-friendly alternatives to rare and toxic elements. By understanding the properties of elements through the periodic table, scientists can develop greener technologies and materials. Lastly, the periodic table is also making its way into space exploration.